reminder about things posted online. In our Schoology page, I put an announcement here about if you are struggling on that Chapter 4 follow-up, you might want to go back and rewatch that video. But also, it's in the Chapter 4 folder. I moved it to be the top thing in that folder, so it's super accessible to you. If you are struggling on the follow-up, and this is why I was just kind of like messing with my microphone before we started recording. This has better audio. It's still not great. My mic was having issues this day, so you got to turn it up a decent amount. But I go through the entire original mastery showing how we got the answers we got. Hey, Major, right now is probably the time to listen and stop doing work. Lake, and same to you. So if you are struggling on any of those problems on the follow-up, probably go back and watch this video. Now remember, I told you this is from, maybe this is from this year. Because I edited the test a little bit. Yeah, I put that +9 after. So this is this year's version of the test. It's all your right answers there. You're doing the follow-up, but it's almost identical. Guys, like it's like different numbers, exact same work. And then another reminder that in Chapter 5 is where anytime people are asking me questions, like if you struggle on the homework. So like I put independent and dependent up here because some people had questions about that. We did the ratio, like Chapter 5 is kind of bigger. So we've got a few things in here already. Answer key is in here, right? But I don't put it top things. I make you scroll a little bit and look at what else is there. Reminder about the math notes. If you are on homework and you don't know what's going on, it's probably in the math notes. So like I'm pretty sure this might have been a problem right from our homework or something similar. We haven't done compound events yet. Like we're getting into that. This is kind of the complicated, not complicated, but like if you just wanted to memorize something, this is like what you'll do in high school. And then this is pretty much what we're talking about today. Tables and trees. So remember, these notes exist. I will print them for you if you come ask me, or you can just use the PDF. 5D we get into tomorrow. The 5D process. So if you're working ahead on homework, realize like they're probably going to say things you don't know yet because I haven't taught you yet. I'd love for you to just be working on the current homework and stay up to date on that. All right, so I got a game. And you and your partner are going to have to make a bet, right, for like what you think is more likely. Or we're not betting anything, right? I know, I've had kids ask me, can we bet like our homework assignments or whatever? No, I mean, I know there's a chance that I lose. I'm not going to make that chance. Like, maybe we can start talking about wagering like a problem or something. But okay, so here's the game. New game. Forget about the dice game from last week, right? New game. Spinner. So imagine, I don't know, what's a game that you've played that's used a spinner? Sure. Sure.
Candyland.
Sure. Yeah, so like a circle where a thing is on and it spins, right? And wherever it lands tells you what to do. So we're going to spin this spinner twice. We're going to take the sum. What is sum? You said it. Say it again. Add them up, right? Sum means add them up. Whether we get a positive or a negative, like that's what you're going to wager on. Are you going to put your money on positive or on negative?
Positive.
Why are you saying positive? So last week when we were working with number cubes, right, which we call dice, you know what a die is, right? You know what's on a number cube. You know what the game essentially is, right? If I roll this, what are my possible results?
1 to 6.
1 to 6, right? What's this spinner look like?
1 to 12.
We don't know. So the first thing you should be asking here is, what's the spinner look like? I want you and your partner to discuss. Don't write anything yet, but if you don't have graph paper, you're gonna need graph paper. So discuss where you think you'd put your money, And then, like, get graph paper if you don't have it.
Grant graph paper to people today.
Ooh, Mrs. Fisher's doing free delivery. I'll be your partner. What do you think? So we're gonna spin it twice, right? And add on. We're gonna bet on positive or negative results. So what are the negatives up there?
Actually, no, after this.
What are the negatives? Out of 4. Another 5. Okay, but what are the negatives? Okay, what are the positives?
Positive or negative?
So it's not just 1 and 2.
Positive, there's a 2 out of 5 chance.
Okay, so 0 wouldn't change anything. What if your first spin was negative, and then you got 0? Or what if your first spin was
How
positive,
many negatives?
and then you got 0?
2 out of 5 for the negatives. How many positives? Is there 0 positive?
Okay. You guys want to play a couple rounds to see how this is going to work and,
Yeah.
and maybe lead your conversation that way?
Yeah.
So remember, we spin twice, add them up. That result is what we care about, right? Positive or negative. So like, we don't need to write anything yet, but in a minute I'm going to ask if there's a way that we could model the chances here. Because like, Liam, what'd you do last week when we were talking about rolling the dice twice? Like, we had 2 dice, but it was essentially we rolled a cube twice. What did you make? I think it was you that made your own. Guys, for dice, and again, these are at the back of the room. If you want one, you are welcome to take one now. I do not need my class set anymore. We called this like dice 1 and dice 2, right? Because I'm rolling this dice twice. The result when I add them up, like what's this bottom right square? What is that? 12, because we're adding them up, right? Okay, so let's try this here. This does not count. So here is spin 1. What is that?
1.
Positive 1, so we're going to add to that a positive 1. What did we get?
2.
You got, so positive, right? So we got positive 2. So our first result, we got a positive. You want to try again?
Yeah.
All right, so spin 1. You got to look to keep me honest. Spin 1. Ooh, 0. Spin 2. Negative 2. Ooh, so now we got 1 positive, 1 negative. For like the experimental, right? Because this is our experiment. Jimmy?
Can I add what we had last time?
Like add with this?
Yeah.
No, because that was its own sum. Yeah, we can only have 2 spins to make the sum. Thank you for asking though, Josh.
I think it's like equal chances get each positive and negative. Since like the 0 is kind of like the in between.
Okay, I kind of agree. Are the positives and negatives equal to each other? Or like opposites of each other? So do you still think it's an like, remember we're adding up. Like what would happen if I did 3 and negative 2? Do I get positive or negative? Positive. What if I do negative 1, negative 2, negative, what about negative 2, positive 1? Negative 1, right, be careful. Positive 3, 0? Hold on, I feel like there's a better way for us to discuss what could happen. Like, on my first spin, guys, come back to me. If you're only half with me, come back to me. On my first spin, what can happen? What are the any? Can I get negative 7?
No.
Then not anything. So on my first spin, what could happen? What's the lowest thing that could happen?
0 is 5.
Negative 2. Next thing? Next lowest?
Negative 1.
Next thing?
0.
Next thing?
1.
Next thing?
3.
So let's be smart about this. Let's set up some kind of table to say, okay, you guys just said the first spin can do negative 2, negative 1, 0, 1, or 3. Guys, let's all try to make the same table by going in this order. So on your paper, draw a box. Yeah, I already got a head start, so I can come in and help people. Draw a box. It's going to be 5 by 5, right? Because we're going to have 5 numbers across the top. We're going to have 5 numbers across the side. We're going to have 5 numbers across the top, 5 numbers across the side. I want to see if you and your partner can fill in that table with what those sums would be. So, like, I want to help you with a couple of these to make sure we start off correctly. What would be the sum in that top left corner? -4. What would be the sum in the bottom right? Bottom right? So you and your partner try to fill in that entire table. We're going to compare how many negative sums, how many positive sums. What has a better chance? Careful with those signs. Watch out for good guys versus bad guys. Well, Mrs. Fisher, I got my results from last week. I need to bring down my class. Just hear that, Mrs. Fisher.
I said older. Because he is older than me.
Will Mrs. Fisher ever be older than me? No, that's just math. She's younger than me now. She'll always be younger than me. I can't really explain that very well. I'll just be honest. I can't really explain it very well. It has to do with like what you eat and how your body processes it. So right now I filled in 1 negative sum and 1 positive sum. So my table right now shows equal chances, but I don't think like I need to fill in the rest of my table. Guys, I don't know why some of you are acting like graph paper is like in short supply. Guys, I literally have feet of graph paper. Like you can make these bigger drawings so you have space for your numbers to go inside. It's hard to read, hard to use if you make it too small. So if you followed my numbers on the outside, like -2, we need to know what is happening for like this spin. So guys, remember, outside your table is what happened on spin 1 or what happened on spin 2. Right? What happened on spin 1 versus spin 2. It doesn't really matter which one is which, because we're going to add them up, right? In addition, we can change the order. Doesn't really matter. Liam?
Sum is addition, right?
Yes, sum is
How do you
addition.
put 9?
You need to fill in the rest of it. You made it a little small. Go get a piece of candy.
That's what I said too.
Did you did you say
I
it
know
to
you
me,
did.
or did you just like say it under your breath?
Well, like I said it out loud to like
Both of you, go get a piece of candy. You need to pay attention and catch my mistakes. I can tell half of us are asleep this morning. 3 and 3 is not 9, unless we're multiplying. What's 3 plus 3? 6. Waiting for you guys, somebody to realize. I deserve. Guys, that's one of the most common mistakes I see people make. Because your brain just says, oh, 3, 3, 9. 3 plus 3 is 6. All right, so I need your help then. Apparently, I need your help. So I'm going to go across the table here. If your table's done, help me out. If your table's not done, double check with me. So what goes here then?
-3.
-3 here.
-2.
Careful here.
-1.
And here.
1.
Ooh, positive. We jump over the 0, right? Check your top row. Okay, next row down. What goes here? What goes here?
-2.
Here.
-1.
I kind of see a pattern. Anyone else sort of see a pattern?
No.
What goes here? Ooh, what goes here?
0.
Oh, now my pattern got goofed up. What goes here? Ooh. So I thought I had a pattern happening, but guys, be careful. Even though it can start to look like there's a pattern, that doesn't mean it's going to keep going. What goes here?
-2.
Ooh. That was just my brain struggling. You guys just caught it quicker than I could even get to my eraser. Next row. Next row. Or sorry, next column.
And then it went 1, 2, 4.
Does 0 count as positive or negative?
Neither.
Neither. Right? It's neither. So if we're only able to bet positive, negative, 0 is just kind of left out of this situation. Bottom row. 3 and negative 2.
1, 2, 2, 3, 4.
Okay, so what is, and let's practice writing this on our paper, what is the probability of positive versus the probability of negative? All right, so my positives I'm going to highlight in green. 1. Crap, that's not positive. Oh, I know, I just started top left because my brain is like start top left. All right, 1. Count them up on your own. I'm not going to count out loud because I know that's kind of annoying.
It's equal.
Ooh, it's almost like the zeros like barricade us off. How many positives? So quit just repeating yourself, show some math to defend what you're saying, or just like wait, because you just keep repeating what you said. Liam's trying to discuss math with you. Sorry, Liam, what'd you say? 12 out of what? Well, what's 5 by 5? How many is that a 5 by 5? 25. What about my negatives? I don't really like using the red highlighter. It's too dark. So I'm going to use yellow for my negatives. How... Ooh, good catch. I just got in the habit because I was excited about asking how many. Because I'm trying to get you to see that what you have been saying is not correct. How many negatives? Is that the same? No.
I feel like there's more positives.
They're all not you feel like, we can see. Guys, it's not like, oh my gut, it's not a gut or a feeling, right? It's math. You can look at this, and this is exactly like those video clips I showed you, that MIT math club that went to Vegas and took it for millions. They were doing math, which isn't cheating, but it's kind of frowned upon. Because the casino can be like, hey, I know what you're doing, get out of here. Like any private place can tell you to get out of there. But my chance of negative here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Out of how many?
25.
So if you had to, where would you put your money? Positive. But, let me ask this. What is your actual, let's say we bet on positive, what's your percent chance to win here? What does percent mean? For every 100. How do I turn 25 into 100? Times 4.
48.
So if we do that on the bottom, we do that on the top. So you here, if I bet on positive, what's my percent chance to win? So what's more likely, you winning or you losing?
You tie it.
If your chance of winning is 48%, what's your chance of losing?
52.
52. So what's more likely, you winning or losing?
Losing.
Still losing. Positives had a better chance, but they're not over 50%. It's due to
Negative is at 40%.
It's due to the zeros. Right? Like, did you have something else? So what if they tell you, though, if you bet on 0, you can triple your money? Right? That's how they get you. That's how the casino gets people. They'll say, well, look, there's 3 zeros here. It's like, what's my chance of 0? Let's calculate that. So probability of 0. Sorry, so how many?
12.
Well, 3
3 out of
over.
3. I mean, of 25. And then
So then to go over 100,
12.
you said times 4. So 12% chance. I mean, that doesn't.
And they get a negative is 40.
Yeah, right. Like,
I mean, I would
None of
love to
these
get
are
it.
better than 50%. None of these are better than 50%.
I think go with one.
Now I want you to think about this for a second. What if we change the rules of the game? We're not just going to spin the spinner twice. We're going to spin the spinner a third time to add in with our numbers. Right? So when we drew this, we said spin number 1, spin number 2.
Oh, this is where we use the new chart you showed us on the site. Right?
So this is where probability tables reach their limit. My table has a width and a length. But if I spin my spinner a third time, where do I put that third spin? Hold on, stick with me. Imagine here, spin number 1, spin number 2, spin number 3 would make it 3, like you'd have a cube of possibilities, and that just feels really tough to draw. You want to go to the 4th dimension? You want to go see a tesseract? Or no, I think I'm saying the wrong. We're not going to the 4th dimension, because that might like destroy the world. What we're gonna do is utilize probability trees. So I got a present for you to make you work less hard, but while I'm passing this out, who wants to read about Scott's ice cream?
Not me. Me. I got it already.
Lakin, go ahead. Scott's job. Shh, listen, Scott's job. It's on your paper. Read along.
Scott's job is at Crazy Creations Ice Cream Shop. It is to design new ice cream flavors. The company has just received some new ingredients, and Scott wants to be sure to try all the possible combinations. He needs to choose one item from each category to create a new flavor.
So, what I want you to write on this handout, because you should keep this in your binder and probably refer back to it a little bit. Why we use probability trees and why tables start to not work. And you can really put this wherever. But the reason why we use a tree, so I would underline, highlight something, is for more than 2 choices. Because Scott doesn't just have ice cream or toppings. There's ice cream flavor, choice 1, toppings, choice 2, and then the syrup that goes on top, choice 3. Guys, now if you had to start by choosing cone or cup, right? He didn't even choose cone or cup anywhere. This isn't even like, we're trying to limit the choices here, but with just this happening, I want you to try to figure out, take like a minute. You remember when I talked the other day about the pizza places saying we have over 1 million different pizzas? I want to, well, they do. So if you watch TV or internet commercials, there are pizza places claiming they have over 1 million combinations of pizza.
Yeah.
They're not lying. I want to know how many combinations Scott has right here with just 2 flavors, 3 sprinkle-ons, and how many syrups? 4. I want you and your partners, you can use this paper. Everything you need is on this paper. Take a moment, chat with each other. How many total possibilities are there? How many total possibilities are there?
24.
Then you can start looking at those questions on your paper. What do you guys think? How so? Can you show me on the tree? Where are we going? Wait, Elias is saying you should stick with 24. I'm confused why you're double. You got 12 from the left. You got 12 from chocolate. there anything else? Because he doesn't have to choose cone or cup, right? That is not actually a choice that he's made.
Oh, I think I know what you said. All of these.
If we had to make the choice of cone or cup, sure, then we could double it again because it'd be twice as many choices. Look, man, if you went like vanilla and sprinkles, I could see like a grape syrup going on.
Oh, yeah.
You know what I mean? Like vanilla, anything can go with vanilla.
People always just put them like cherries on.
What about chocolate?
Why have I not used any cards today?
Oh, no.
Caroline, what's your thoughts?
One of the pyramid.
Caroline's saying 24. Jackson, what are you thinking? Did you say 30? Sorry, I couldn't hear you. So like 3-0? Okay, Jackson saying 30. Liam?
24 and 32.
Ooh, or. Why are you debating? Like, why are you...
If it has to have flavor, sprinkles, and
You have to pick one of each. So what are you going with now that I tell you have to make a choice? 24. Owen, thoughts? So it seems like most of us are saying 24. Let's look at the why. How many flavors does he have to choose from? 2. Let's assume he chooses vanilla. Right? So that's why the bold line here. How many sprinkle-ons does he have to choose from?
3.
And you only get to choose one. Right, I heard some of you saying, what if I want like 2? You only can choose one. So here it shows that he chose toffee. And then we have our syrup. How many syrup choices are there?
4.
4, right? And you guys have this on your paper. So I would maybe on your paper put like a 2, a 3, and a 4. Might be under the binder. Flipped over right there. No, it's that paper. Alright, so if he had chosen hazelnut, though, what are the syrup choices out here? Ooh, so out here, guys, let's go ahead and apricot, plum, berry, grape. What about if he chose vanilla and sprinkles? Still apricot, plum, berry, grape. And you guys can figure out what we're doing here. We're going to fill in all of these. So can you pick up your pencil and fill these in with us, please? Here's the biggest part where people try to make mistakes. If he has to choose one of each of these, is this vanilla here one of the final choices? No. Is this toffee bits here one of the final choices? No. So his final, his total. I'd maybe put this on your paper if I was you. I'm not collecting this paper. It's for you guys. Your total choices come from the very end of the tree. We do not count the things we chose along the way. We only choose, so if we follow this bold line, what ice cream, what sundae did he make? Vanilla toffee with plum. Sounds interesting, but I've never tried plum syrup, so I'm not going to judge. So how many did we say there were total here? 24. Can anyone spot a way that we could have gotten to 24 without making a tree? Take a moment. I want you to think with each other. We made a choice between 2. Then we made a choice between 3. Then we made a choice between 4, and we have all those choices on our handout paper here.
It looks like a pyramid in that trading.
It kind of does, right? Actually, when people talk about pyramid schemes, this is why. Because there's a person at the top who's making most of the money, and all the people down at the bottom are not in a very good situation. So this is where people like have coined that term pyramid scheme. But that would be like if people are paying money up the pyramid, right? Because they'd be paying up. Anyone able to figure out how we could get to 24 here? Liam?
4 times 6.
Or if I say it a bit longer, hey guys, Liam's telling us a giant shortcut. We could have gotten to 24 by doing this 2, this 3, and this 4 are choices. It's literally how many choices you make, all multiplied by each other. So we had made 2 choices for flavor of ice cream, 3 choices for the sprinkle on, and 4 choices for the syrup. If you multiply choices by choices by choices, you get the total amount of options. That's way faster than making a tree. However, here's where the tree really comes in convenient. What's the probability of getting an ice cream that involves plum? I don't care about flavor. I don't care about sprinkle on.
1 in 4.
What's the probability we involve plum?
1 in 4.
Well, let's check. Plum here, plum there, plum there, plum there, plum there. How many plums out here?
6.
So our probability of plum, 6 over what?
24.
24 totals, and that reduces to...
1 in 4.
Oh yeah, because plum was one of my 4 syrups.
We got 1 4.
We didn't really have to unreduce. Like, it's one of my 4 syrups, right? If I look right here, what's my chance of plum? It's 1 out of 4. Questions about this? Why? Because ice cream's delicious. Maybe not every combination here. Maybe not every combo here is delicious.
Depends on the ice cream. If it's vanilla with sprinkles, delicious. If it's vanilla with plum.
So then our final question here. What's our chance that Scott's ice cream... Do I have to remind you daily what classroom appropriate behavior is? Stop with the fake screaming. It is not appropriate. Do you understand? I can wait. Do you understand? Are you going to try and change that behavior or just keep doing the thing I keep telling you not to? Sorry guys, I want to give you as much time to work on your homework as we can, but I gotta teach what I gotta teach. What's our chance it will involve hazelnuts? I don't care about flavor of ice cream. I don't care about syrup. What's the chance that we involve hazelnuts? Not leaving. Not leaving it. Give me somebody else. I should have grabbed my cards. Josh?
1 out of 3.
How'd you figure that out?
Because there's 3 choices of chunky mix in.
So we could... Sorry, go ahead.
And like, there's 3 choices of chunky mix in, and hazelnuts is 1 of the 3.
Yeah. If you have to use one of each of these. Now, we could have gone back to our table and said, like, how many have hazelnut? Well, there's hazelnut, and down there there'd be hazelnut, and we could do, like, 2 out of 6. Right at that. Or, all of these involve hazelnuts. Right? All of these down here involve... Or Josh just said, well, if I just look at where hazelnut comes from, what'd you say the reduced fraction is?
1 out of 3.
1 out of 3. Because hazelnuts is one of the 3 mix-ins. So then just one more vocab word if you encounter it on your homework. Mutually. What's it mean to like mutual? Like if you have a mutual understanding of something. Yeah, it's like together, right? Like mutual means like together. Jim, you with me? Mutual means together. What's it mean to exclude? To not include, right? Like get rid of or say you're out of here. Hey, look up here. Because I highly doubt if I asked you right now, you would know what this is. So mutually exclusive means together they have no results in common. I don't think this is on today or tomorrow's homework, but if you see it, mutually exclusive literally just means like nothing in common. So vanilla ice cream versus chocolate ice cream, they're mutually exclusive. They don't have any common because you had to pick one of the flavors, right? They'd be exclusive because they split up. And I think that's... We got like two... So hold on. We're not going to solve this problem necessarily, but I want you to think about it. Scott, Rona. Sorry, I was going to go back to Scott. Rona's getting ready in the morning. Just listen to this situation. I want you to just test your brain. Table or tree? This is the question. Would we use a table or a tree? Rona's getting ready and needs to choose one shirt. I actually should erase this and re-highlight. Maybe. All right. Here's Rona's outfit for today. Don't question the clothes we don't pick out. One shirt. One pair of pants. That apparently she has 3 different pairs of pants. Shirts. Okay. How many choices did she make?
Not that many.
She chose shirt. She chose pants. How many choices?
2.
2. Could we use a table?
Yes.
Yes. Could we use a tree?
Yes.
Yeah. You could do either. I don't know if we'll pick up here tomorrow or just move on from this, but that is all the time we got now. Have a great day, guys.